computer. That will create a complexity because we need real-time access. This is one thing, but that could be thought through a network. We'll come to that in a second. But the other thing, what is great being out of the box, is that you could connect few boxes to it, for example, or few computers or few workstations. And this is then in 2010, we were kind of ready of making one device that wasn't called Horus by then, but basically an external box. When suddenly, it was even a bit earlier, 2009, when suddenly a company called Odinate came to see us, and not only us, many other factions, and saying, look, that's what we design, a network audio-based interconnection and all of that. And we thought, that is very interesting. That is even hyper interesting. But we would like actually to manage the signal that goes through this black box called Odinate today, that everybody knows under Dante. Okay. So they were constructing a closed network where you have an input and an output, but you don't know what's happening in the middle. And for us, it always has been, for merging, it always has been important to be able to understand and to manage and to fine-tune what happens in the audio, because not only we want pristine audio in 44.1 and 48, but we also go higher in sample rates, up to DSD signals today in DSD 256, so that, or DXD, so that we can not only interconnect those devices, but also manage what's happening and understand what's happening and get the best out of it. The funny thing, or the good thing, is that this experience with Odinate didn't only happen to us, it happened to many other manufacturers, and a few of them we got together and we decided, well, let's create something, a network based on this idea, but that is open, okay, and that opens those boundaries. And so this is how our first network device then was a little bit delayed in its availability, because we then integrated this open network called Ravenna. Okay, that was the first network, and this was in Ravenna.
Okay.
This was where, for the little story, why does anyone know why? That's a little hidden door thing. No? Is that Dante, the poet, the Italian poet, but Dante, the network Dante, died in a city, in an Italian city, which is called
Ravenna.
And this is why a few manufacturers sat together, and specifically there was of course a need of also financial investment, and those financial investment came mainly from Lavo, who had their own interests around this. And then this is how Ravenna started to exist, and Ravenna is based on open IP protocols, a bit more recent than Dante, than Odinate. So this is why they are interoperable in some ways. We're going to see how or why, but they have more recent protocols, and this is why they can do a bit more things or do things differently. So this brings me to to give you a little bit of background of the history. This brings me now to our ecosystem, or let's say product line, if you want, that we have today. On the left side, we have a new chip that is called Z-Man in two variations, basically one 64 by 64 in and outputs, and the other one 256 by 256. And Anubis, that I will show a little bit later, is our first product containing this new chip and this new DSP, basically, chip and FPGA that allows us to do many things. We also OEM this product, so it means that other manufacturers also have that inside in their own products. Then underneath we will have the Horus, we'll talk about this also, the Happy, which is a smaller converter, all those over IP, and very below the Nadak. I'm not gonna touch this tonight, I'm just gonna say this is a high-end consumer product for audiophiles. We are, as merging, not only with the converters, but also Pyramix, the software, for example, very famous for high-end recording in concert halls, in acoustic music and things like that. And the audiophile people, the people who want to have something relevant at home as well, would like to have the same quality with the same converters than it has been recorded. This is why they have asked us to, some of those audiophiles have asked us to develop a product for them. That is of course then plug and play, that has a complete different aspect. There's no Pyramix or whatever behind it. It's just a converter with a Roon player inside, for those who know Roon, that can play back up to DSD-256 as well, and you can have it either in stereo or in 7.1 or 5.1 plus 2 in terms of a home playback device and manager, media manager on that aspect. Then we have on the top of it, in the middle, our two drivers. Those drivers, this is the concept. We have an ecosystem, which of course is in the idea that we think that is a good ecosystem, but we are very conscious that culturally or due to XYZ reasons or simply because you're used to something else, you can take some of those elements and put it into an ecosystem, another ecosystem, or you can take another element and bring it into this ecosystem. Okay, so we provide drivers, for example, for workstations, for DAWs, on the core audio side, on the Mac side, and on the Azure side, from the PC side. So that means you can literally connect every type of workstation to our converters. Okay, several at the same time, or just one. We can see that a little bit later. The thing is that you can have 128 physical in and output streams at the same time with one of this driver in one FS. Okay? The architecture of a Mac and of a PC is a little bit different when we go higher in sample rate. We will see that in a second. And on the right side, we have Animan, that stands for Audio Network Manager. As we are network based now, we are interconnecting basically our old style patch that we see here, but this is done virtually, of course, via Animan, where you can interconnect different devices. The nice thing of that is that, of course, you can interconnect our own drivers and hardware devices, but it's open to other manufacturers. So today you have Neumann, you have Genelec, you have Ross Video, you have Archwave that does Genelec and other things, you have Direct Out, there will be Lavo in the future, and so on, that are also available on that interconnecting or virtual patch, let's call it like this, in there. One thing to be said, I don't know exactly what all you guys are doing, but we see that today the audio industry is, of course there's still some people doing only music or genre of music, some others just mastering, some others just post-production, some whatever, live, AV and all of that. But we nevertheless see a strong merging also in terms of all these different aspects or angles of what we can see how to work in an industry. So in terms of the studio environment, we also see more and more that you would have some platforms or some softwares that you will use in a specific aspect, for example in an immersive audio environment, and to process something, and another computer to do something else, to make something creative via Max MSP or whatever it is. And the beauty of that is that you can also interconnect in and outputs from one software to another. Okay, that means that you need one hardware device, a Happy or Horus or an Anubis, to be able to provide a clock to the network environment, but then you can interconnect all those different devices the way you want, okay, through this patch. Below we have a Pyramix digital audio workstation, recording, mixing, mastering, editing, and so on. Innovation. I can happily talk later about those software products. I'm not going to talk a lot about it now in my presentation, but just give you the little feedback. Is that Ovation is basically coming from Pyramix, but used for theaters, theme parks, installations, museums, and all of that. It's a non-linear, there's no timeline, it's object-based playout system, show synchronizer, show whatever, in the sense that you can have an audio media, interaction rules on different aspects. When it reaches rules, this rule means that open this microphone, switch on this light, do this or play this file, or get the information from the light show guy who will send you an information to do this, okay? Or it can be an operator also with effects and all of that in multi-track and all of that. Good. Below, a few logos and a few things. The two interesting one, or one interesting one at least, is the ST2110 on the complete right side. Are you familiar with that? Does this ring a bell? Nothing. Okay. We just talked about audio over IP. I'm not saying that everyone, there's still tons of people working with traditional analog digital audio. I'm not saying, well, you absolutely to move on. No, but it provides some flexibility, so many reasons why, at least if you envisage a new installation or a new project, to go audio for IP. Then we can discuss if it's Dante, Ravenna, or something else, or AVB and so on. That's another aspect of it. But what is clear is that it provides, instead of having point-to-point connection, it provides a point-to-switch to multicast. So you broadcast basically your signal to many different places that exactly without lossless, without any problem on the network. Okay, and you have redundancy as well if you wish to, for a cheap bracket price compared to MADI, ACBU, analog with big cables and all of that. So flexibility in all of this. So you have one big device on the stage, where you have your XYZ numbers of 20 microphones or whatever, and you just have one network cable coming to you, or two if you want redundancy, and you have everything, all the traffic going on those networks.
So that is a format? Or your
No,
standard?
I'm talking about the philosophical, or the technical aspect of audio over IP. Okay, then we have protocols, we have manufacturers, we have commercial little wars going on. We can talk about Ordinate, Dante, A67, Ravenna, AVB, all of that. Some compatible, some are not, and all of that. But the concept is there. And this is something in the audio industry that is quite mature today. Everybody kind of knows, yeah, audio over IP, I can use it, and so on. The guys in the video are living the same thing, but from the beginning. So, and you can imagine in the video, audio is already complex, but the video, it's a bit more complex, but you have much more money also inside, so it's going to be a much slower process. Nevertheless, ST2110 is a norm done by the SMPTE, so the Sound and Motion Picture Technological Expertise.
Picture engineers. Yeah.
Sorry?
Society of Motion Picture and Television Engineers.
Television engineers, thank you. And they worked for many years on a norm, because the SDI cable that you have in every broadcast environment or TV environment will become a 1 gigabit Ethernet, 10 gigabit Ethernet, fiber, 100 gigabit Ethernet cable in the coming years. So today, I'm just taking the example of Canada as we're here. CBC in Montreal, they have, perhaps you know that, they have to move from the old tower, from their building, into a new facility because whatever reasons, real estate and so on. But they're not going to make an SDI infrastructure. They're going to make an Ethernet infrastructure. Okay, and because there's a norm, that means that they can take video devices from one manufacturer, video devices from another manufacturer, and that theoretically they can interconnect. Okay, then that's the theory and the practicality as well. But you have to put some knowledge and some fiddling around it there. Just to make it short, ST2110 has different subgroups. Obviously, a video group has a metadata group and has an audio group. That's called ST2110-30. And this part of the audio group is actually the AS67. They just retook AS67, which is a norm. Okay, we talked about Ravenna, AVB, Dante. Those are closed protocols done by a group of manufacturers. And then there's an audio norm called AS67, done by the Audio Engineering Society, that is open. And luckily, Ravenna talks to AS67, Dante can talk to AS67 as well. Okay, so you can take this AS67, put it into the ST2110, so that means that the AS67 devices that you're gonna use or acquire or whatever are ST2110 interoperable. So it means that if you're I don't know exactly what you're all doing, but if your little studio or your audio obi-van or your production company or whatever acquires those type of systems, you're open to be able to produce content, audio content for the video guys, okay, which makes it very flexible afterwards on that aspect. And this is important to talk about that. Great. Coming a little bit into Horus and Happy, these are our traditional converters. On the left side, this is the Horus. On the right side is the Happy. On the left side this is 2 units with a touchscreen on the front, and this is the back picture. This back picture has, to explain you quickly, at the bottom all the digital in and outputs: 24 ACBU, 64 MADI optic and coaxial, extendable to 128. And on the left side, you have the word clock input if needed, and breakout cable for LTC, media, and so on. And on the top, you have 6 slots where you see those DB25s. Those 6 slots can be populated with each time 8 tracks, either inputs with AD and mic pre's, either outputs, DAs, or you have some cards where you have 8 inputs with mic pre's and 8 outputs, DA. So if you fill it up completely, you could go up to 48 in and outputs with microphone preamplificator, 128 MADI, 24 ACBU on 2 units. Okay. So it makes a lot of possibilities. You can also split signals, meaning that you can have an analog input published to the network and at the same time output on the ACBU and on the MADI if you need to replicate something that you need to feed somewhere else. You have different types of cards, 2 families. You have what we call standard converters that are already very good and high quality, but in terms of its conversion they stop at 192 kilohertz. And then what we have what we call the premium family that goes up to DSD and DXD and has also a better specification in its mic pre components. But those premium cards cannot be in and output at the same time, they can be only in or output. But you would understand that you can mix and match all those different cards. So it means that if I'm in my project only need outputs, I can only put DA cards. Or if I decide that I have like 5 microphones that I want to have them the best quality possible, and then I have spot microphones that need to be good quality as well, but where I can make a little compromise. So I could have some pure premium cards and some normal cards at the same time. Okay, so that would work together. But of course, it would be limited if I want to do DSD, for example. If I'm somebody doing DSD, then I would have only the premium cards being available for the DSD part of it, so that I can mix and match those things. There's also 2 things to say. On the right side, I have a power redundancy. That means that the system is redundant in terms of its weak point, like every device, the power supply is the redundant part of it when I do live things or stuff like that. So I have a redundancy on that aspect that becomes mandatory for over 24 microphone inputs, but to switch it on for the phantom power. But once it's on, it becomes a redundancy again. And there was another thing I wanted to say. Oh yeah, there's also one card called PT64. This is specifically to connect it to a Pro Tools HD. So I could have there's Pro Tools here. I could have up to 128 in and outputs via Pro Tools HD and benefit from all this high quality in and outputs from the Horus. On the right side I have a Happy, same technicity, same architecture, same possibilities. It's only a smaller device, 1 unit. This is the guy. You have 8 ASCBU, 8 ADAT, and you have 2 slots. So you could put 16 ADDA with mic pre's, for example, or you could put 1 MADI card and a DDA, for example. Okay. So this is our combination of our different converters.
Or a Pro Tools card and a MADI.
Or a Pro Tools card and a
That's
MADI,
the
64
right,
channels, 64 channels. You can really mix and match it the way you want.
Yeah.
Just quickly, these are our drivers. So you could have, I said up to 128 in and outputs in a core audio device or in a Azure device on a PC, on a Windows. Now, because of the architecture of the operating system, when you go higher in the sample rate, the behavior of the number of channels changes. So they are the same in the Mac, but up to 192 kilohertz, but they divided by 2 on the PC side, but you see that on the PC side you can go much higher than 192, which you can't on the Mac. So, yeah, this is something to know if you are interested in those higher sample rates. This is something to be taken into account when you decide.
Why is that?
That's the architecture of the OS. That's how it is. It's okay. Just to give you a little hint, is that on the Mac side, the audio in the Mac side is actually in the OS called Core Audio,
Right.
and this is why you can manage it directly from the OS in that way. But the OS doesn't allow to go higher than 192. For them, it's like doesn't exist. So this is why you can't go higher. In the Windows side of it, actually the ASIO is something that doesn't exist in Windows. It's a backdoor, the ASIO. Okay. Normally the Windows audio driver is VWDM, something like that.
WDM.
Thank you. So Windows Media Driver, exactly. Of course they can't do that, and this is totally, it's just to play back an audio file.
Yeah.
And it's full of jitter and irrelevant. So this is why there is ASIO, but which is a backdoor, so you can tweak the architecture to go higher. because the architecture doesn't know even that it exists. Okay, so this is why there are some differences on that. So that means also, this is where we are convinced of today, since a while already, but that we provide, of course, as you saw, software solutions as digital audio workstations, but today, because of the price of them also, that you would use the positive points of all of them. You won't run all your life just the Pyramix or just the Pro Tools or just the Logic. You will do, yeah, now I need to do that, so I use a Logic, and because that's really good for it. And the next day, I use a Sequoia because this is where it's good for that type of job. And you just change it, and you have the same hardware. Okay, so it makes it not only flexible, but it makes it also being productive in the sense of using the right tools for the right job. And of course, you can also have several devices of them on the same network, sharing an in and output on the same device. The only limitation on that, it has to be the same sample rate, physically, yeah, on one device. But if you have two devices, you can have two sample rates that are different. I mean, if I have Studio A here, Studio B there, and I have one Happy there and one Horus here, with one, I don't know, Logic there and one Pro Tools here, I can have two sessions going on, one in 96 there, one in 48 here. And the next day I have a bigger recording where I would like to need to use all the inputs from my Happy and my Horus because I have a big orchestra. Then I would have to run the whole facility in the same sample rate, of course. So I have those choices.
So is it completely expandable, those boxes? Like, can I only run 48, or can I go as high as I want, like 96 ins and outs? And can you go higher than in the...
So physically, those boxes have slots.
Mm-hmm.
So once you fill them up, you add another box.
Okay.
As it is on the network, you can have 3 boxes. I give you one example. I was at University of Georgia in the US at the beginning of the week. They have 3 concert halls, mm-hmm. And 1 control room with 4 Pyramixes, and they have also Sequoia there. This is because they train the students in there. That's why they have 4 workstations in there. But they have access, due to the network, to all the different concert halls. And in each concert hall, they have 2 Happies. So that means that they can need more in and outputs. They add another Happy there, and they have 3 suddenly. It's a switch. So I come to the infrastructure here in a second, but I have a switch here. Mm. And this switch has, this time, 8 connectors, but it could have 10, you could have 48, and just connect it onto the network. I mean, then there are some, when I say 48, there are some limitations about how many channels. It's perhaps better to add a second switch and whatever. But there we're entering into bigger scale installations. But yes, I mean, that's the concept of it.
And then the redundancy as well on top of that. If you but the redundancies from the computer.
Yeah, I mean, there are different redundancies. Yeah. There are the redundancies of the hardware device in terms of the converter, the power supply, right. And then the cable, of course, the switch, and the workstation. But you could have, and this is the beauty of it, you could have this device on stage, or the bigger one, independently of how many channels, you can scale this. But you have one device on stage, you have a switch on stage, so that means that there are 2 cables, one on the right side of the hole, one on the left side of the hole, going back into a control room where you have another switch, or simply connected to 2 workstations. And you have the same signal going to a laptop, just as a backup, and a main system, which is your full-blown system because you need some editing, some EQs.
If one crashes,
yeah,
it was still working.
And it's not only the application if it crashes. Even if the hard drive is crashing, you still have the other computer running.
Right.
So you that's then your own kind of what budget do you have to do that to be able to scale your thing.
So you have 256 channels is your max, which means
256.
Yeah.
Why?
I'm asking. Well, because it's on the previous thing.
Okay, we have no. This is what is sitting on the computer. So the computer, the digital audio workstation, can handle 128 in and outputs.
Okay.
More.
All right.
Okay.
Yeah.
But one Ethernet. But this is then limited because of the core audio driver or the Azure driver.
Mm-hmm.
Okay. Then this is where we enter then into our MassCore engine, to go back to Pyramix, mm-hmm. where we can manage 384 in and outputs on one cable simultaneously in one FS.
Okay, so
okay.
384.
But
channels.
why that? Because we bypass Windows,
right.
or the OS. Here we don't. We're still.
So how does that translate, or how many Horuses could you have in one go?
The bottleneck is not the Horuses. The
The
bottleneck
cable.
is this going to your workstation.
No, and okay, all right, but,
And this going to your workstation has 420 channels, bidirectional.
right.
So
you
is
could
it,
have two.
so is it more dependent on the switch?
No, it's dependent on the 1 gigabit Ethernet cable.
Oh, okay.
Okay.
That bandwidth.
Because this is going at the end. This is the bottleneck going to one workstation.
Right.
You could run two workstations and you multiply it by 2,
Mhm.
and they can be synced together. But it means when you start to edit them later on,
Yeah.
it will be a
This
bit
could be-
complicated, but you can still do it.
Right.
Can you just attach them together without the cable?
Why not?
Wireless.
No, that gives you already a lot of flexibility.
Yeah,
But
I
your
know,
que-
but I just wanted to know what, okay, on one Ethernet cable, one computer, what's your maximum input output? You're saying-
420 1FS bidirectional streams.
So that means you could put, that's a lot of Horuses.
It's a
Divide
lot.
by
Oh,
eight.
That's 10 Horuses, basically.
Divide by 8.
48 times 10 is 480.
8 or 9. 410.
Yeah, so that's what I'm saying.
Yeah.
I'm just trying to get that.
Yeah, yeah.
So in other words,
To the
I could have
scale.
a truck with,
Of course.
yeah,
Yeah.
I was recording a huge orchestra or
But you'd go at a higher
sporting
sample.
event or something.
You'd go at a higher sample rate, so you
You
know, you
stack
go
it by
2
2.
times, you'd go 4 times that fast, right?
Yeah, but no, but you're talking 1FS.
I'm talking 1FS,
Yeah.
so
So
it means that
44.1,
if I go to 192, I would
Yeah.
divide it by 2. So I can still carry 100 channels bidirectional in one Ethernet gigabit.
At 192.
At 192.
100 channels.
Yeah, roughly.
Okay, and how many DSD channels?
It's 64.
64, and that's F. That's DSD1,
No, DSD4, DSD 256.
256.
Yeah.
Okay, which is okay.
So it gives some scaling.
Yeah, no, I
possibilities.
know your previous question. I was just want to
Yeah.
Yeah, of
understand
course.
what what's the max.
Yeah.
Of course, but this is kind of dimension. But then there is what you're gonna feed from one device to another through one cable,
Mhm.
and there is what you're gonna feed to the network. And as soon as you have switches, several switches, you divide all of that because you have several cables connecting to those switches.
Right.
Okay, but it's the bottleneck is the one cable going to the workstation, for example.
Yeah. Now, in some big shows, though, you'll have, like, when you have a large show and you've got, say, 5 top name bands, and they all want their own
System, yeah.
thing, so you need that many channels on a rock show. Or a TV show, like on a big country network show,
Yeah.
and they don't want all those channels. They want them all separate.
Yeah, but as far as I understand, they want them all separate, but they don't want them at the same time.
No, but that's what I mean. But there are a lot of times the EQ settings and everything all set up for that band. Then they'll have they want a whole other set
But
of
then it's
inputs
a
here.
total recall of
Yeah.
the
Preset.
the console or the workstation
Yeah.
or whatever
Yeah.
it is. Yeah.
But it just means that you do need to have way more inputs than you would think.
Yeah.
It's crazy,
Yeah.
but they do.
Yeah,
I know
Just
from-
for the mic side.
yeah,
Yeah.
the mic side, yeah.
yeah. Okay. That brings me to this little device here, Anubis. This little device has 3 functionalities. It is first of all a little sound card, a little converter, high quality. It is secondly a little monitoring section, always with this in and output. I come to that what it has in a second. And then it's a remote control, okay, for our IP basically streams or outputs. So first of all, let's start with the beginning. We have here 2 mic inputs, okay, that can be of course line inputs, that are with a double preamp.
Light on.
Sorry.
That's just so. Maybe we should put a light on because
Yeah. Okay. Yeah.
You're backlit there. Unless everybody can see it.
Okay. I can pass it afterwards anyway.
Oh my God.
Well, you have something in between. You have 2 mic pre's per input together in a line, so that means you can go up to 137 dB dynamic range. So it's very comfortable on that aspect. You don't need to wiggle much about the gain. These are the inputs. You have 2 inputs here, 3 and 4, which are line inputs or high impedance instrument inputs. Okay. Then you have 2 outputs here, XLR symmetrical, and you have 2 jack, but also symmetrical outputs, 3 and 4 there. You have 2 independent headphone circuitries, Okay, that are for those who have a horse or are happy. Those outputs here are arguable in terms of their qualities. They have been thought and designed. This is something to check, basically, to have sound. Is it working? Yeah, there is some sound and so on, but it's not a proper quality headphone output. Here, it's really enhanced. This is high quality output in the first sense, and it's also open to very diverse impedances of the headphones themselves. Then we have behind again GPIO 1 in and one output. It could be a pedal or red light or whatever. This can be also converted to a MIDI over jack breakout. It's one or the other, so that you would have some MIDI machine control, stuff like that. Then you have your network connector, AS67 Ravenna, and you have your DC input. Your DC input is with a little wiggle, so it means you put it in, you have to twist it, and so that it doesn't get away. And the interesting thing is that this input, this network input, is power over Ethernet. So that means that you don't need the DC input, or if you put it in, the DC input becomes a redundancy, or vice versa, on the power supply. Then you have the on-off here, and you have a little Kensington lock. For those who could imagine at a school, or in an environment where you have several boxes, where you have a lot of traffic, people coming in and out and whatever, you can put a Kensington lock, and you can move it until the cable is there. Then on the bottom you have a mic stand, a little input. This is European size, so we provide the adapters for the US size, so you can put it on the mic. And one thing to understand, so this is aluminium, so this is the cooling also of the box. I mean, you need it in Montreal in winter time. It's a bit warm and so on. But no, it will always be a bit warm, okay? So don't be afraid. Now, you never hold it like I would hold it anyway when you work. You just touch it so you don't feel it really. And you have little holes here, and you have a ventilator there. This ventilator doesn't work, doesn't function actually. It functions also, it's a security. It functions only when it reaches 52 degrees. Now, since 2 months that they're available, it happened only once to me. I was in a production sitting with a rooftop window, and by pure, not chance, but I didn't pay attention, the sun was going on it. And after 2 hours, suddenly I heard it like, oh yeah, okay, that's security for the box actually. So it is in those extreme environments.
It sends you a signal, an audio signal?
No, you hear it, the ventilator.
A fan.
It's a fan.
Oh, it's a little fan.
Yeah,
inside.
some people are like, yeah, but I don't want to have a fan on my device, and whatever.
It's not very
and actually,
loud.
it's not a fan.
It's hard to hear.
It is a security fan. It's really because your device is in danger, because the sun wasn't there, that it needs to cool
It's
down.
just keeping it cool.
Yeah, exactly. But normally it doesn't work that way.
Wow.
Okay? So I'm gonna run you through a few windows. You can pass this if you want, so you can look at it at the same time. So the idea now is that, and I can show you here, but it's better to see it on the screen. The idea is that you have on the bottom, you have this triangle. This will get you into the menus or whatever if you press a bit and so on. Then you have 4 soft knobs, A, B, and 1 and 2. The AB is basically for 2 monitoring sets, but these are the soft keys. This is when we have a queue then, what we call a queue, where we can then, independently of the monitoring, select what we want to send to that queue, okay? This is then the input thing, where we have the 48 volt for the microphone, mic line, we have a little symbol that we can link those 2 guys together. The XLR, for example, is a cuff mute, so that means that you don't disengage the gain or all of that, you just click it, and it mutes it so that the person can cough or put his finger in his nose or whatever it is, and continue then.
This is the software interface? I'm sorry.
Yeah, that's the software interface. So it means that here, if I go a little bit louder, now I remove the cough button that I have here, and I can just simply mute it and cut it. To explain here what I have, that's perhaps interesting. So I have my microphone input that is connected in this device. Then this device goes analog out, so it converts once. It goes analog out in sources. I can create whatever I want, okay? And those can come in, and those can be sent either via a workstation or a play device, or via some hardware devices, okay? I can either choose one or the other. And then at the right side, I have again the sum, the peak, the reference level, the dim, and you see the CD3Q1. Those are virtual other monitors that I created and other headphones that I created, more than the soft knobs. And a queue is one of those queue I was telling you earlier that will have a different selection of those sources coming in. So the cool thing about that is that now I could say, oh, but my C monitoring is actually something I would like to use all the time, so I would put it on the soft knob. I have those options and possibilities to manage the device the way I want it. This is then my setup page. So you will see it later when you approach a little bit, but when I press a little bit longer, I will go here into the setting page. And this setting page, I can do many things, but this is where I would set up, for example, a source that can be local or that can come from somewhere. That could be stereo, 3.1, 4.1, 5.1, 7.1 plus 4, or whatever it is, up to 32 channels in one, channels in one single source, okay? Same thing for the outputs. So now, this is my monitoring page. Again, I would have my different speaker sets. I could imagine my speaker set A is stereo. I have two outputs here, two main outputs. These would be my stereo speakers. I could say, well, I would like on the B to be 5.1. Great, I could still make a compromise. I would have output 1, 2, 3, 4, and I could use one of the headphone output as being my output 5 and 6 for my channel 5 and 6 for the surround, for the 5.1. That would be those symmetrical and the other one asymmetrical and the other one symmetrical, but it's still a compromise. Or I could use on the C, for example, that would be a 7.1 plus 4. That's what I decided to. And then I would use a hardware device to attack my 12 speakers over that. Okay? So I can really scale it the way I wanted on the aspect. Then the very cool thing, this is a web browser. For those who are familiar with merging, each of my pre's directly in the workstation and so on, but the setting up is also on a web browser like this. Now, this with Anubis has been done a little bit differently, in the sense that it has been thought that you might have the mic pre here that you can connect and locally manage. So this is my mic pre input 1 and 2, this is my 3 and 4 here in the front. This is now my talkback. I have a little dot here where there's a little microphone, so I can manage my talkback also. This is not implemented yet, but this will come. I can scroll through other pages to be able to also control the inputs coming from other devices like Happy and Horus. But I could at the same time have a laptop or a little touchscreen there with an iPad and have this open. And this will be my monitoring page all the time. Where I see on the left side, I select my sources. What do I want to listen to? And on the right side, I check or I select my speaker sets. And then in the middle, I have my speakers available on that speaker set with the different down mixers, with the different polarity, solo X, mute, and so on, polarity invert, and so on from the speakers. Okay, so it's a real proper monitoring section. And this is then the possibilities of what Anubis can manage. So I have, of course, a limitation where I can go up to 8 monitors doing 22.2 and whatever. It's a 256 by 256 framework, okay? And then it has to fit in there. I also have, in terms of the monitoring section, some bass management. I can add a crossover with a frequency that I can choose with up to 36 dB per octave frequency. Yes, sorry, how you say that? Slow, thank you.
Sure.
And with a trim and a delay for each speaker as well that I can manage. Okay. So this goes and is all with it. So that means that if we have a little setup, what we have here, but a bit bigger, I have my Anubis, I have my different inputs, microphone, instruments with a talkback, headphone, local with some little stereo speakers, and I go over the network to record to a workstation or several workstations. And I have then via switch again to a bigger in and output device, like a Horus or whatever, to have my big spot microphones and my big outputs for the speakers. And all of that is scalable, of course, okay? I wanted just to make it clear. We are today in a world, at least those doing a bit more than 5.1, where we have to get ready that one day you will be asked to do 7.1 plus 4, the next day you will be asked to do some oral, the day afterwards some stereo, and so on and so on. So a monitoring section and all connected via AS67 makes it very flexible for you to be able to manage those type of things through the monitoring. One or two aspects that for me are interesting to look at back to AS67, we talked a little bit about before. It is ST2110 ready, as we said, for the video guys. It is compatible with Ravenna. It is also compatible with Dante AS67. So there I want to just make a little comment. It's not Dante, it's Dante AS67. There's some Dante cards that are not labeled Dante AS67, and that will not be compatible, okay? So you have to be very aware that is AS67, yes?
Are they all layer 3? Like, I thought that.
This is all layer 3. If we talk about layer 2, that will be AVB.
Yeah.
Okay, for those, are any of you doing live stuff? No, okay. But for those in the live side of it, Mayor Sound is doing AVB, GBL is doing AVB, Soundscape is doing AVB, Acoustic is doing AVB. Why? Because it's a form of a roadie format, in the sense that you don't mess around, there's no IP, you don't mess around about that, you just connect, klung, and it works. You know, you go from one place to another. But then it makes total sense today. All those formats are logical in the way they work. The Ravenna is more the broadcast side of it, the Dante is more the live but studio environment, and the AVB is more the PA side of it. But the idea is that you can combine all those different type of formats. For the moment, the AVB is still a bit complex to combine, but the Dante and the Ravenna side of it, you can do it via AS67. And so that creates interoperability. But then the advantages of the AS67 is that you can have multi-sample rates in a studio environment, in different studios, for example, on the same network, and you have high track counts. If we talk about immersive audio or higher sample rates, then the high track count enters into something serious, where in the Dante world you're limited about this. Okay, so these are a few advantages about that. Talking about the Animan quickly, you see here a simple installation. I can also open the live Animan here, but let's do it this way. On the left side, you have all the devices that are available on my network now, and you see the interconnection of those that I've done with the mattress on the right side. So the mattress on the right side dynamically changes depending on what tools you select. And then once you interconnect some tools, you can also repeat several outputs to several different tools, again for redundancy and this type of things. Then simply the lines or the interconnections will show up on the left side. Two interesting things you can do with it. First of all, you can save your configuration, of course, so that you have a configuration where you can record outside. You have another configuration when you're back in your studio and so on. And the second thing is that we don't see it that well on that screen, but here you have a gray area actually. You can make it green if you want, but called sample rate zone, and you can create several sample rate zones. That means that you elect a king or a queen that is master of that sample rate zone, that you put where the crown is on the top, and that means that all the devices that you put into this zone inside, when you change the sample rate of the queen or the king, it will change the sample rate of all the devices at the same time. So you can define studios or zones, that is studio, again, studio A, studio B, and you put the devices inside here, and I want to have a production 192, so I change to 192, and all the devices that are on that network in this sample rate zone will also go into 192 at the same time without bothering the others. Okay, the others remain where they are. Of course, then the potential interconnection that you would have had between studio A and B, changing the sample rate, will then disappear, because you would have a connection between a 48K and a 192, and that wouldn't work. Sorry. Okay, well that's the idea. Good. With Anubis, we are in we call that missions. We are in progressing different steps and forward of firmwares. So today we are finishing what we call the monitoring mission. That means that kind of all of what I explained is today available. The thing that is not available is the remote control of the Happy and the Horus mic pre's that will come. And the other thing that is not available is that you can save and recall presets via the web browser. Okay? But this is something in the coming weeks that will come. But other than that, the monitoring mission, there will always be some fine-tuning, of course, but it's kind of getting to an end. And we will start to work on the music mission, and there will be other missions. What will the music machine be, or what is the concept of it, is not changing a device, is that once it will be ready, you will receive an update of the firmware. You update the firmware of that, and actually it uses the same hardware devices, the same FPGA, the same DSP, but with simply another interface. So the mixer that we have for the monitoring will not speak to a guy recording his guitar and trying to make some monitor. He wants to have faders, I mean like here, auxiliary sends, and that's it. So you will benefit from those evolutions in those firmwares because you have the hardware device just by updating the firmware. Okay? So this will all come in due time, bit by bit, on that aspect. All right? Cool. A few users around the world. Well, a few users, universities, high schools, and so on.
McGill.
And so on. Yeah.
Those guys are such
Yes.
slackers.
I was gonna say, so Horace is like the like the big daddy, and then Happy is like the small.
Happy. That's exactly, Happy is the son of Horus.
Happy
in
is the
that-
son of Horus.
And it is true. Yes, but it's more a matter of scaling. It is more a matter of what do you need for your project today. You can start with a Anubis, so if you don't need many IOs, and then scale it up. I mean, it all depends what you need to do. Now, the thing to know and to understand between the Happy and the Horus, who have the same architecture, and the Anubis, is that the Happy and the Horus don't have DSP inside. So you can convert channels, you can split channels, but you cannot sum channels. Okay? Where the Anubis has DSP inside, so you can sum channels, you can then EQ channels, you can then dynamically change channels, and so on. The EQ is not there, the dynamic is not there, but this will come. So you have DSP inside to be able to do that. Okay? So there's a little difference. That's why you can do the monitoring also, because you can do down mixes, sum, and all of that. Yes, please.
How does the, I guess the Horse handle like long distance bandwidth of?
Cables, you mean?
Yeah.
That comes down to infrastructure. You can use Cat5.
So it's not a limitation of the unit.
No, it's not a limitation of the unit. It's the limitation of
Cat
cables.
5e is extended and
Cat-
Cat 6 is
Exactly.
and Cat 7 is
Exactly.
longer.
Just
Right,
longer.
Yeah, just longer.
Yeah,
Right.
it's longer. Then you can go optical as well. There's switches. I mean, if you have, let's say, here an infrastructure, and on the other side of the building or the building next door another infrastructure, what people would do, they would have a switch where you have on this switch some optical connectors, then have an optical to the other building, and have a same switch on the other side so that you can interconnect.
Whatever.
Yeah, I mean, this is an
Yeah.
infrastructure then thing, but a Cat5e cable, standard cable, or Cat 6 cable shouldn't be longer than 30, 40 meters. This is roughly the
Right. Okay.
way you should stand with.
Can you talk about the converters that you guys use and some of the clocking technology, that kind of stuff? Is that, or should I even ask, is that a stupid question?
No,
just
it's not a
amazing.
stupid, but what, you mean the way we clock the devices together, that's what
Yeah.
you mean?
Well, just in terms of like, I mean,
Quality.
yeah, just in terms of quality.
In terms of quality, as I said, 137 dB dynamic range. What is interesting on the Anubis, so to be very clear, on a Happy and Horus we have cards, okay,
Right.
that you put in, and two families, one premium, one
Right.
standard card. And we are
On the
now.
Anubis.
Sorry?
On the Anubis.
Yeah, once. I'm
Okay.
hopping to the Anubis in 1 second. We are now on the 4th generation of the cards, okay? Because new chips, because we're getting older also, so we're getting wiser, so we learn things. And we try, of course, to reinforce the quality of those converters each time we add a new chip and so on. That means that for those who have older cards, we have either a trade-in that is possible if they want to go to the newer cards, or we keep as much as possible some older cards also if they need more, so that they can fit to the color, if they want to. But then they can also mismatch different cards from different revisions. Then this is now, this is the 4th generation now. We made 3 generations in those cards. This is the 4th generation, where we went even a little bit better in terms of its conversion quality. And what we added, as I said, we have 2 preamps, so we have a 137 dB dynamic range. But those 2 preamps can also be driven individually. So it means that typically a front of house and monitoring can have each one his gain. Okay, then you don't have the 137 dB dynamic range, but you have two independent gain triggering that two different people can manage. Okay, this is not the case in the Happy Other Horse. Yes.
Yeah, this might be dumb, but I'm new to this, obviously, audio for IP.
Yeah.
But this GPIO, what is that?
Oh, that's something completely different. This is you certainly.
General
Should-
purpose, it's a general purpose switch. I mean, GPI, is that you're talking about?
Yeah. You know the.
Like a foot
Because I
switch,
see this on here.
mechanical, just anything, if you want to turn on a red light when you're
Exactly.
recording, so every time you push your record button, the red light comes on in
Oh,
the studio.
very
Or
cool.
a foot switch for talk back, rather than
Okay.
so your hands are free.
Very
You're on your
cool.
keyboard, you can use that to, for.
Okay.
That's a it's just a general purpose interface. GPI, we call them GPIs, I don't know why you call them GPI.
GP. No, because you have
G-
inputs and outputs.
Okay.
General
For the
purpose
red light, you need an
instead of-
output,
Here
and
it
for the
is.
pedal, you need an
Yeah.
input.
It has GPIO and
One.
MIDI.
No, it's either or.
Right.
You
Okay.
cannot
So
use
you
both
switch
at the
one
same
on,
time.
you switch-
Yeah.
yeah.
Okay.
Okay.
There's only 5 wires.
But then most of the time, I mean, if you need one GP, because you have just a small device. I take an example for a journalist doing a show outside somewhere, having two microphones. He wants a red light, he wants the talk back with a pedal, whatever. He doesn't care about MIDI on that aspect because it's a small infrastructure. Then you put it into a bigger infrastructure where you want MIDI, for example, because you would like to remote control some stuff. But then that means that the GPIO would need more than one also in and output because you have several red lights, several things. Then you would have a device on your workstation via USB having those relays being able to switch on and off. But GPIOs is a very, I'm not criticizing, but it's a very old style of concepting a
True.
studio, but very important when you have it public, when you have many people working in there, because those lights, those things, those fader starts and those things are common to an engineering background. Okay, but if you conceptualize your own studio, you don't need it.
That's how I conceptualize my studio. That's another story.
No, but you know,
Pickles, I
we are
don't
then
need that.
always in between providing solutions for an institution that has many people working with it, and they follow rules, they follow concepts, they follow schools, and so on. And somebody who is working on his own, on her own, then they do whatever they want. You know?
I think to answer your question, he asked the question about the quality of the converter.
Oh, sorry, the
and
mic,
things
please. Yeah.
Yeah, but the converted stuff like that. I'm selling my Big Ben and my Antelope because the audio over IP is more sample accurate than your Antelope clock. You don't need
Really?
word clock.
Wow.
It's better than word. Yeah.
It's a million times better.
The quality.
I don't know where we're going.
I was running digital audio Denmark, the DAD. That was my converter that I was used. And when I was testing out your basic one, and I went, no, the DAD just let me. Yeah, well, yeah, you guys used to use them, right?
Yeah, you're
The
kinda
original
like
Horus
that,
was
yeah.
built by them. But you know, it was like this. But
It
when
was
you're
called Sphinx, but-
your old
Sphinx.
yeah, the Sphinx.
I remember that, yeah.
When your latest card came in, the thing, when I
AKD.
heard that, I just went, oh my god,
Yeah.
this beats the DAD,
Yeah.
which up until this point, that's an expensive mastering
Yeah.
box, right? And up until this point, nothing's been beating the DAD, but your latest card
Thank you.
beat the DAD, so it's gone.
But why is-
But no, so clocking.
Why is Pro Tools using DAD now? Like,
Because they're behind.
Because because at least
They couldn't come up with something on their
The
own.
NTRX, because at least they have better converters than they had before. I mean, DAD is not a bad converter, to be very clear.
No,
it's still a
it's
good
excellent.
converter.
No, I mean the DAD. That's what I'm saying. It took up until your previous card wasn't as good as the DAD, but your latest card beat it. So it's really an upper echelon of audio, the DAD.
And so the MTRX, I mean, DAD are still good converters.
Yeah.
So
No.
no doubt. And at least now Pro Tools has some good converters, which they didn't.
I
Only
really
took-
wanted Derek here to do the drum roll to find out what the retail price of that box is.
Get back here, Derek. Come on. We need a drum roll. You'll be pleasantly surprised.
Okay.
I let you talk about the
Do you
price.
plan to expand the line? Like, might there be a 4-input or an 8-input device?
For the moment, this is how it is.
Yeah, okay.
Okay. Of course, there are ideas.
Yeah.
But it's far too early to discuss this. This is 2 months old.
Yeah.
So if something is coming, it won't be this year. It will
No.
will be next year or whatever.
That's impressive.
And the better mic, if you get the premium version of that, are the mic pre's different?
Yeah, basically they're not different. The architecture is not different.
No, I mean-
it's the selection of the elements
Okay.
is a little bit tighter. I mean tighter.
Yeah.
That gives us a little bit more higher specs.
Yeah, okay, good.
Audio over IP, I don't, you know, I was very doubtful of it until I heard it.
Yeah.
And I was like, oh my God.
Well, hearing is one thing.
But how can you clock all that stuff?
Well,
So accurately when it's just a Cat5, you know,
It-
going
it
to a
is-
network and.
audio of IP, it is quite interesting to understand the background. Is that it uses protocols from the IEEE
Sure.
document,
Right.
so it's open, and IP is used, of course, in the bureaucratic since many years. And when people were looking about indeed having a clock, because in the digital domain you need a clock somewhere, so one of the clock was the PTP and the precision time protocol as
Yeah,
well.
yeah.
And this comes from the finance world. It's basically when you change or when you send your millions from Hong Kong to Montreal or
Right.
to
Yeah,
Toronto,
yeah.
that in 1 nanosecond they're from your account in Hong Kong in Toronto.
Right.
So it's GPS driven also.
Right.
And so it's a nanosecond based clocking, precise clocking.
It comes from the finance.
Yeah, it comes from the finance.
$2 million.
Where's my money?
You were a nanosecond late, you bastard. Charging interest.
Who's gonna miss?
And of course that has been then implemented and adapted, but that is
Right.
why it's so precise. And
So
the
that's
GPS
why.
on that aspect is not needed,
Right.
but you could. What people typically in the ST2110 domain afterwards,
Right.
they like the GPS because at the same time it gives you the geolocalization.
Right.
And you could still in a nanosecond and still going through some switches and whatever, could even calculate from a distance the latency that you would use to go from one point in the audio stream or the video stream from one
Right.
point to another, so that you can automatically compensate it. But these are then other type of
Lip sync.
yeah. Well, yeah. Exactly. But this is why it sounds good. Now, PTP is one thing. Then, I mean, we put a lot of effort of making good analogic circuitry as well, and summing as well. And so there's this aspect as well.
Oh, no, that's not saying the sound quality was, you know,
Yeah,
I was really blown away. And
that's
that
great.
was,
Thanks.
you know, well, because I couldn't see anything beating the DAD. I'd try everything, try this, try that, you know, and the quality that you have in your sound, it was always been a brown sound, which is warm, fuzzy, or clinical clear. And it was always drove me nuts because I want both. I want a warm sounding, but yet sharp,
Yeah.
clear
Yeah.
sounding. And the world's always been, you know, a British brown, you know, was warm, but it's no definition. Or this is absolute Japanese, precise,
German.
very precise,
Yeah.
but there's no warmth in it, right? And that's the one thing I noticed with the DAD was that they sort
Yeah,
of
yeah.
were in between. They had this both.
Yeah.
And then, so in your latest cards, when I heard that, I went, oh my God, that's what I
Going this
want.
direction.
Well, I want that absolute, you know, precise transient
Yeah,
definition,
yeah.
but I still want that warmth of the
Yeah.
female vocal,
Yeah.
right?
Kind of like old millennia preamps.
Yeah. No, it's like I use any acoustic guitar, anything.
Yeah.
I use Millennia preamps for any mandolins or any acoustic
The
instrument.
acoustic stuff.
Yeah.
The interesting thing is that, of course, sound is primarily important, but then the flexibility of IP is huge. I mean, I know many tone masters today. They go record around the world. They have their laptop in one hand, a Happy or a Horus in the other hand, depending on how many entries they need. And the rest is that I need this mic there, this mic there, this mic there. It's rental, boom, put there, and that's it.
Well, the guy that clued me into this stuff is Fabio.
Mm-hmm.
He runs the credit department at Long McQuaid. He also is an opera singer and likes recording orchestras.
Yeah.
And maybe you know.
No,
He's-
I don't.
He's the guy that turned me on to this
Yeah.
stuff. I'm going, no, really?
He did some emerging stuff
Yeah.
early on.
Yeah.
Loved it.
Yeah.
So,
He recorded the Brazilian orchestra.
was his brother, I think.
Mhm.
Yeah.
Yeah.
Great.
Yeah, I mean, you have I mean, all the big operas and classical recordings and so on are done by German freaks and others, US also, but they use that since many years because of sound quality, but also because of the flexibility. Because those are guys who need to be very quick in terms of setup, being able to travel lightly because they don't have the same budget as before anymore, and so on. So this all plays a role in that.
Brilliant.
So.
How much?
Well, you
It's
think
Canadian refit.
you would think that something like this would be worth like what, 5,000? Well, how many channels? There's 2 in, 2 out. So if they were like $2,000 a channel, like a mic preamp like that would be worth, it would be $4,000, right? If you were looking at one of those guys there, they're like $2,000 a piece each channel, right? Right? And this thing does like a million other things. Look at a Grace, like a Grace 8-channel monitoring box, right? What's that? $4,500 for that thing?
Dangerous,
Or Dangerous Music, those things, right? So this guy here, the 192 kilohertz Pro version of this, is mapped, like street price is $2,149.
That's not bad.
Did you pick it?
I was off. I was a little off.
Yeah.
I was gonna go to that number.
Yeah, and then the premium version, of course, costs about, I think it's $650 more or something like that.
So, the premium version.
The premium version is the DSD version. This goes to 192K.
Oh, okay.
Right.
That's actually
Like
really
like
good.
Converters are different.
the Peter Moore version, I should say,
They are
is a
the
little bit
same.
more.
I mean, the converters can go higher to DSD if you want to, but the selection of the analog elements for the mic pre and so on are a little bit preciser on the premium version, so that the specs are a little bit.
And that'll
It does
be,
sound better. The
and that
premium
will,
card-
Of course.
Whatever frequency.
Is that
you're-
Windows
Yeah, it doesn't matter. That's why I bought them. I'm not even doing you DSD.
No, no.
But the sonic
No,
quality of
no,
the premium
no, you
card.
could
I
still-
remember paying $2,200
so what's the
for
Mac
the
Windows
Rosa
thing? That's the,
200.
Yeah.
Well, that is like a core audio. Like if say if you're running Pyrmix or something like that.
No, it's not.
Well, we should talk to him about that to clarify that, because like I'm used to running only in Windows, right? Windows 10.
You should.
You
once.
should, it'll blow you away.
But don't you have to down convert all the time?
No, we don't doubt, yeah, there's a lot of problems with it,
Ultimately.
right? A lot of problems with it, because it's a 1-bit system, which means you can't edit it. You can't do a punch in on it and stuff, whatever, so there are, but if you're doing analog and digital, back and forth, then, you can, stuff, I'm just saying though, somebody's gotta invent a way of editing DSD.
Well, we did 20 years back.
Well, no, but it's not really, you mean the DXD?
I mean,
Yeah, but DXD is not, it does not sound the same.
I agree, it doesn't sound the same, but it sounds very good as well.
Yes, but, okay, what I'm saying is, with this modern DS, we should be able to do, somebody should be able to write a way of doing
I
it.
mean, editing a 1-bit signal, it's kind of there, it's in our pipe, but it's hungry in terms of processing. But
Yeah, but that's, nowadays, we're approaching it, anyway.
Yeah, no.
That's another argument, I just wanna say, with DSD, it's microdynamics. The reason you love vinyl is that when the guy's playing the brushes on the drums, and he's just slightly getting a little louder, on a PCM recording, you don't hear that. You just hear this constant, on the brush hitting the drum, right? On a vinyl record, you hear that slight
So the dynamics
human,
aren't scaled.
yes, microdynamics.
Right,
It's,
right.
which
Right.
our brain loves. We love microdynamics,
There's a
right?
difference between MIDI on a piano and an acoustic piano.
Yeah, exactly. No,
It's
true.
not as
No,
extreme,
No, but no, it
but
is. It's microdynamics.
Yeah.
Those individual things, and that's the thing with DSD is that you play Brubeck Take 5 and you listen to that on DSD recording, you go holy fuck, and then you switch to a 192 recording, sounds very good, but the drum
not
just
there.
sounds like he's hitting the drum the same way every time, right? When you hear the DSD,
But
you
there are
the
two
sound
things
of
to
it.
be said about DSD. The first thing is that what he explains, we all have trained ears or whatever because it's our job.
Sure.
But where it's becoming really convincing then is that if you have at home your DAC DSD 256 to crappy speakers, crappy cables, the difference is even higher because the definition of each sample that is then converted is so narrow, so small that you have a beautiful sound again, even with crappy speakers, and that and crappy cables and so on, and that makes then really a decision to the auditor. That brings me then to the next point: is that DSD was done in late 90s by Sony and Philips to replace the CDs. They were gaining, I think, $4 million per year because of the license. So it was a big income for them in terms of the technical license of the CD.
Initially.
Yeah, for 20 years.
Oh, for 20 years.
Yeah, for 20. The technical
Yeah, it's
license
always
lasts
20 years.
20 years.
Yeah,
Royalties.
yeah, yeah.
And
So-
royalties. And then after the late 90s, that was gone. So they came back with something they did in the 70s, but the processing was too big. Is to do actually a 1-bit signal in higher sample rate frequencies.
Oh, well, actually, the competitor was DBX that came up with it.
Yes.
'Cause I remember I used to do Lucasfilms, and we had the DBX 700
Yeah.
on the 1-inch video machines to
Okay.
do the duplication.
Okay.
Lucasfilm would only use it, and the DBX actually invented. Here's the difference. PCM, pulse code modulation. That's what we use. You use tons of real estate because you have to measure. Okay, here's 0. Okay, where's the top of the wave? Okay, put that data here. Measure it again. Put that data here. Put that data. So you get tons and tons of data. Delta code modulation, which is what we're talking about. It's okay. Where were you? Where are you now? Like in other words, I'm just recording the change, the delta.
Yeah.
I'm recording, but that means I could do it at 2.8 megahertz sampling, not 44.1, which means my dots on that analog curve are fucking
64 times.
Yeah.
64 times.
So you get this. You're getting an amazing, accurate picture of the microdynamics. But now we're going from 64 times. That's what Sony used 44.1 times 64 to come up with 2.8.
Yeah, we're ending ladder logic going smooth, yeah.
No, we are today at 11.2 megahertz sample rate. So 256 times 44.1, and there are even some people doing 512. We don't do that now, but there's a big difference between the 64 and the 256.
Oh yeah, there is.
That's huge. I
Yeah.
wasn't a fan of the
Yeah.
64 personally because there was some noise shipping, some filtering
Yeah.
on the top, which was like, but the 256 is amazing. It's really amazing. And what I wanted to say a second, which is very interesting, is that today you have a business model in the production. When Sony and Philips came out with this in the early 2000s or late 90s, they wanted to reinforce a new materialized format called SSCD and so on that still exists today, but it was already in those days like people didn't want to change players anymore, didn't want to rebuy a full collection of records and all of that, and it was the beginning of indeed MP3, but iTunes and all of that.
But don't forget, DVD audio was Betamax VHS.
But it was also DVD audio.
Sony
was
is
also
not part of the old world.
Yeah.
Sony he's irreverent according to the Japanese, and he sides with Philips. And then you had Warner Brothers, who were owned by Toshiba, which did DVD audio. So there was a battle between SACD and DVD audio, and Napster came in through the middle
Yeah,
and
MP3s
MP3
came along.
won. Yeah, because they're battling over
Yeah,
this.
but I mean, cassettes won over vinyl. I mean,
no, I don't think so.
No, not at
It was
all.
a convenience
The
thing.
interesting thing too.
Yes,
It was a
but
convenience.
everyone had a cassette and a turntable.
Yes, that's right.
But the
if you
very
take the cassette in your
Yeah, yeah.
Walkman, you put the cassette in your car,
Yeah.
Yeah.
but you play vinyl at home.
You tape your
the very
records
interesting
and
thing
play them so you don't
today
wear out your records.
is that during I would say 10 years, DSD was kind of dead.
Yeah,
Some
yeah.
minimum people were doing it, and suddenly the bandwidth of internet started to 5 years back, between 5 and 10 years back, started to grow. So you can envisage, stream or download a DSD file at home, and today,
Well, 5G, when the 5G network hits,
of course.
we'll be able to play DSD files
Exactly.
on your phone.
So the thing is that today, not the majors yet,
Yeah.
for plenty of different reasons, but all the independent labels in all various different type of genre, really going from really heavy metal because they're very keen on to some high fidelity, of course, to the classical stuff, contemporary jazz, world music, and all of that.
Definitely
Basically,
EDM.
acoustic stuff. Many of those independent labels are producing today in DSD, and because there is a financial business model on that, you have the delivery, and the listener, the audiophile, will download a $30 album in DSD. He will have all the rest, or she will have all the rest down PCM and so on. But they prefer going for the higher price because they have the DAC at home instead of going for the crappy MP3. And so it works. There are people making proper living out of it. Artists, managers, producers, and so on.
I mean, that's in a weird way. That's why vinyl is making a small
As well.
insurgence. Because you can actually make money as an artist on it because it's a physical medium involved.
Well, yeah, but you go to a swag table, and your T-shirt $25 or the
Yeah,
vinyl's $25. It's like, oh fuck, I'll take the vinyl, you know. Well, like my daughter was buying vinyl, she didn't even have a turntable. It was an object of art. You know, for her, it was just like, oh wow, this is. She already has a T-shirt, so now she has the vinyl, and it's an object of art, you know. So I finally set her up with a turntable.
She was like, how does it work?
Yeah.
You know,
What
you
do you?
can't run your turntable from your Apple phone.
Are you sure about that?
There's a, they have an app.
It's the next upgrade on this unit.
It's like,
So anyway, I mean, if there are questions, let's have a drink. If there are questions, or you have other, are there other questions or?
The only question I have is okay, how many headphone, are you limited to how many headphone keys? My big problem is I need to run like, I do a lot live off the floor. So I want 8 independent headphones. And sometimes I want more because I have other artists coming in, he's overdubbing on this.
You can, as far as I know, you can create as many monitors as you want. Let's create a few more.
Cues.
The impedance.
Yeah, but
No,
I
no,
call
no,
it.
just
I
like
call,
this is
It's
the
not
control.
outputs.
'Cause
Outputs.
I call it
the
a
window only
monitor.
gives you 4, right? Like the window only gives you 4 cues, and I need 8.
Gotcha.
So I have to make, yes, I can go into the thing and I can make a, you know, and yeah, I can do a send off
It's
a channel
one
strip
where
like
it's
that,
on
but it's not as convenient as having those in the window. It's amazing when you have the cues there, just like you're looking at all the cues and somebody say, hey man, I need a little more boom, bass, and you know, before you even finish the sentence, you know, got it going for them.
One for
Yeah.
one for every musician. That's what they're for.
The mic stand.
On the mic
That's
stand,
what I was kinda
every
wondering,
musician
right?
has.
It's
Yeah.
the-
I find all these personal headphone cue systems the worst thing at going because no musician knows how to run it properly, and it's like you get in somebody's car with the old equalizer and everything's pushed to the top. So it's like the musicians are going, oh, I can't hear more bass like this.
Gotta be this knob.
Yeah, they're all up at the top, right? So it's a good engineer knows what a drummer needs to hear. You know what, you know, because always people always say that and you go, oh fuck man, like, you know, how's your headphone cues? Perfect, like, you know, because they know what they need. And to me, it's like the better quality headphone cues you can give somebody in a session,
The better
performance.
right.
If I'm asking,
Totally.
you to play the best guitar in your life,
And you wanna hear it.
I gotta do my job. I gotta give you the best monitoring that I can in
Yeah.
my life, you know?
Or get rid of headsets entirely.
Well, that's lovely, but
There's a
it's,
guy that did do that, Nashville engineer.
There's a lot of
Like,
people
it's in
doing that.
Paris. What's his name again? Anyway,
yeah, I know,
he
the
did
guy in
like the-
Toronto did it on one mic too, that
you
church.
do like the phase
That
reverse
asshole.
stuff.
Yeah, an asshole.
What's that?
Remember that jerk?
One mic.
There was no headphones there, I know. No, I know what you're saying, but headphones, that's a reality. I mean, you know, if I
Cause the
can,
space is a problem always.
it's always a space and it's,
You need to hear it back the way it's being
Oh, it's his phone 6 now.
transmitted, You know what I mean?
So I created, I think as maximum as I can. I created 1,
that's the
2,
thing,
3,
my
4,
balance
5,
headphones, they
6,
slow the doors.
7.
I've done balance headphones my whole.
7.
7.
On one box.
On
That
one
little
box. And how easy is it to, how can you be, if,
Well, you need I/O. Like you need output.
No, the
well,
output's
that's
over
what
here.
I'm doing that already. The reason I have 48 channels is I have
so you can-
32
yeah, you can
input
use your
and I
wires for
have,
those, yeah.
the rest of my stuff is just for headphones.
Yeah.
I know it's kind of crazy using it, but I mean, what else can I do? Right? Nobody builds I wish somebody would build